surface area with parametric equations. We know that the surface area is 2 pi times the integral of the radius times the differential arc length ds, where 2 pi radius is the circumference of the rotation. If a curve is rotated about the x-axis, the surface result has an area of 2 pi times the integral of the radius y times the differential arc length ds. If a curve is rotated about the y-axis, then the surface area is 2 pi the integrals of x ds, where the differential ds is the square root of dx over dt squared plus dy over dt squared dt. A parametric curve is given by x of t and y of t, where x of t is f of t and y of t is g of t. That is, we have an equation for x in terms of t and an equation for y in terms of t. We then use these equations, either x or y, and plug them into the formula. We also use these two equations to find the corresponding dx dt and dy dt in the differential arc length formula. If these equations are not given, we might have to parameterize the curve ourselves. For example, calculate the area of the surface obtained by rotating the parametric curve t, t cubed about the x-axis. Since the curve is rotated about the x-axis, the radius is the vertical distance y. Thus, the surface area is 2 pi times the integral of y, the differential ds. We were given x equals t and y equals t cubed. Dx dt is 1. dy dt is 3t squared. Thus, the differential ds is the square root of dx dt squared plus dy dt squared dt. But dx dt is 1. dy dt is 3t squared. Simplifying this, we have 1 plus 9t to the fourth, the square root of, then dt. The surface area is therefore 2 pi, the integral of y is t cubed, ds is the square root of 1 plus 9t to the fourth dt. The lower limit of integration is 0 and the upper limit of integration is 1. Using u substitution, let u equals 1 plus 9t to the fourth, then du is 36t cubed dt. Thus the surface area is 2 pi. In terms of u, the lower limit of integration is now 1 plus 9 times 0, which is 1. The upper limit of integration is now 1 plus 9 times 1 to the fourth, which is 10. T cubed dt is now 1 over 36 du, and the square root of 1 plus 9t to the fourth is now the square root of u. The surface area is therefore pi over 18, the integral from 1 to 10, u to the 1/2 du. Evaluate this integral to obtain pi over 27, 10 to the 3/2 minus 1. This is roughly 3.5631.